In this video, we're going to work on some problems that relates to hypothesis testing of the population mean. So let's start with this one. Number 1, a factory has a machine that dispenses 80 milliliters of fluid in a bottle. An employee believes the average amount of fluid is not 80 milliliters. Using 40 samples, he measures the average amount dispensed by the machine to be 78 milliliters with a standard deviation of 2.5. Part A. State the null and alternative hypotheses. Now feel free to pause the video if you want to try this problem yourself. So let's go ahead and begin. So let's start with the null hypothesis. So this is going to be the status quo. This is the machine in the factory. It dispenses an average of 80 milliliters. Now the alternative hypothesis, this is what is being tested. The employee, he believes that the average amount of fluid is not 80, and so he's conducting a test to show that's the case. So we could say that mu does not equal 80 for the alternative hypothesis. Now part B, at a 95% confidence level, is there enough evidence to support the idea that the machine is not working properly? What would you say? Well, first we need to determine what type of test we're going to do. Is this a one-tailed test or a two-tailed test? The fact that the alternative hypothesis does not equal 80, that means it could be more than 80 or less than 80. It could be on the left side or on the right side. We need to conduct a two-tailed test. So let's draw a normal distribution, and we're going to shade the area to the left and the area to the right. Now the confidence level is 95%, so that's 0.95, which means the area of the shaded region is 0.025 on both sides. Now the z-value that corresponds to a 95% confidence level is 1.96. So these are the critical values. They separate the rejection region from the fail to reject region. The shaded area is the rejection region. Now, in order to determine if we should accept or reject the null hypothesis, we need to calculate the z-value and compare it to the critical z-value, which is 1.96, positive or negative. Now let's write down what we know. So we know that the sample mean is 78, the sample standard deviation is 2.5, and the sample size is 40. Now, if the sample size was less than 30, we may have to use the student's t-distribution. But the fact that it's greater than 30, we could use the normal distribution and get the z-score, since n is large enough. So we're going to use this formula. It's going to be x bar minus the hypothesized mean over the sample standard deviation divided by the square root of n. So x bar is 78. The hypothesized mean is 80. The sample standard deviation is 2.5 over the square root of 40. 78 minus 80, that's going to be negative 2. And 2.5 divided by the square root of 40, as a decimal, it's about 0.39528. So negative 2 divided by that number gives us a calculated z-value of approximately negative 5.06. Now, if we place that on the number line, on the graph, it's in the far left. So notice that it's in the shaded area, the rejection region. So this tells us that we should reject the null hypothesis. So we could say that with a 95% level of confidence, we cannot accept the null hypothesis that the average amount of fluid dispensed by the machine is 80 milliliters. So with 95% confidence, we believe that the machine is not working properly. And that's all we could do for this problem. That's it. Now, before we move on to the next problem, there's something I do want to mention, because I simply stated that for a 95% confidence level, the z-value is 1.96. And due to the symmetry, if you know the right side, you know the left side. But I didn't mention how to get it. I did cover this in another video. So if you go to YouTube and if you type in how to find the z-score, given the confidence level of a normal distribution, if you type in those exact words and maybe add organic chemistry tutor after that, you should see a video that comes up. And it explains how to get this z-value given the confidence level. And once you get this first z-value, the other one's going to be the same, just negative due to the symmetry. So I just want to mention that for those of you who had questions about how I got that number. Hopefully you already know by this point, but if you do have questions, check out that video. Number 2, a company manufactures car batteries with an average lifespan of 2 or more years. An engineer believes this value to be less. Using 10 samples, he measures the average lifespan to be 1.8 years with a standard deviation of 0.15. Part A, state the null and alternative hypotheses. So go ahead and try this problem. So once again, let's start with the null hypothesis. So the company manufactures car batteries with an average lifespan of 2 or more years. So this tells us that the null hypothesis is that the mean is equal to or greater than 2. Now, for the alternative hypothesis, we need to look at the engineer. He believes this value to be less. So he's the one that's going to conduct the experiment. So he believes that the mean is less than 2 years. So that's it for part A. Now, what type of test are we going to deal with? Is this a 2-tail test or a 1-tail test? Now, for the alternative hypothesis, if the mean was equal to 2, it would be a 2-tail test. But because it's less than 2, I take that back. If the mean did not equal 2, let's say if the mean said it doesn't equal 2, for the alternative hypothesis, that would be a 2-tail test. But since the mean is less than 2, it's a 1-tail test, but specifically a left-tail test. So let's begin with a picture. So in part B, we're dealing with a 99% confidence level. So the area of the region that is not shaded, that's 0.99. Alpha represents the area that is shaded, that's 0.01. So that's our left tail normal distribution. Now, what type of test statistic are we using here? Should we use the z-test or the t-test? What would you say? Well, let's write down what we know. So the engineer is going to use 10 samples. That means n is 10. He measures the average lifespan to be 1.8 years, so that's the sample mean. The sample standard deviation is 0.15. And we know that the hypothesized mean is 2 or more. So we're going to put 2 for this value. Now, notice that the sample size is less than 30. So that tells us that we should use the t-distribution, plus we don't know the population standard deviation. We know the sample standard deviation. So when these two conditions are met, if you don't know the population standard deviation, and if the sample size is less than 30, that's a good indication that you should use the t-test as opposed to the z-test. But first, we need to determine the t-value that corresponds to our critical value. So we need to go to the student's t-distribution table, which I'm going to do shortly. So here is the student's t-distribution table, but this one is a 1-tail test, not a 2-tail test. As you can see, the area lies on one side of the curve. Now, our sample size was 10, and so the degrees of freedom is going to be n minus 1, which is 10 minus 1, or 9. So we need to locate 9 in the first column. So that's the row that we have. Our answer is going to be somewhere in this row. Now the next thing we need to look at is our alpha value. So alpha lies only in one side of the curve, and our alpha value was 0.01, which is here. So that means that our t-value is 2.8214, or I'm just going to round it to 2.82. Whoops, what happened there? Now, it's positive 2.82 on the right, but it's negative 2.82 on the left. Now, for the particular problem that we're dealing with, the area under the curve was shaded on the left side. So we're going to use negative 2.82 as our t-value. So we have a critical t-value of negative 2.82. So now we need to find our calculated t-value and compare it to our critical t-value. So the formula we're going to use is this one. It's going to be the sample mean minus the hypothesized mean divided by the sample standard deviation over the square root of n. So the sample mean is 1.8. Mu, or rather mu naught, that's going to be 2. Our sample standard deviation is 0.15, and the sample size is 10. So 1.8 minus 2 is negative 0.2. And then 0.15 divided by the square root of 10, that's approximately 0.047434. So dividing those two numbers, our calculated t-value is going to be approximately negative 4.22. So if we compare our calculated t-value with the critical t-value, would you say we need to reject the null hypothesis, or should we fail to reject or accept the null hypothesis? What would you say? Well, our calculated t-value is in the shaded area. It's in the rejection region. So that means we should reject the null hypothesis. Therefore, we could say that with a 99% level of confidence, we cannot accept the null hypothesis that the average lifespan of the car batteries is 2 or more years. We could say that with 99% confidence, we believe that there is enough evidence to discard the null hypothesis. And that's all we could say for this problem. So that would be our conclusion. That's it for this video. That's all I got. Hopefully these two problems helped you to understand how to perform hypothesis testing and how to determine whether or not you should accept or reject the null hypothesis. So thanks again for watching, and don't forget to subscribe to this channel.